Okay, let's talk about section 1.7, transformations. Okay, so in the last section, we talked about just general graphing, and we really just relied on plotting points and finding patterns. So we should have sort of a list of things, of functions and their graphs that we can just kind of immediately draw a picture of. For example, like y equal x, we should be able to just immediately draw this one, right? It's that line that goes through the origin. It's got the point 1, 1 on it. It's got the point negative 1 on it, right? We know what that looks like. We got to know what this one looks like. And we can rattle off a bunch of points, maybe say a few words about the domain here, right? So, or domain in this case, remember we need all of the radicand, anything that we can put in that radicand of an even indexed radical, we need that to be positive or 0. So that's going to be 0 or, and so on, right? So domain here, maybe I'll just write it. Domain is all the real numbers that are bigger than or equal to 0. That's infinity right there. Okay, so we can rattle off a bunch of points that belong to this one, right? We got 0, 0 on there. We got 1 goes with 1. 1, 2, 3, 4 goes with 2. And, we can just plot a bunch of points, right? We also should know this one, x squared. That one's our standard parabola. We'll talk more about quadratic functions in general later in a specific section. But for now, we just know what the general parabola looks like, right? Like x squared. We could probably draw y equal x cubed as well. And again, if we don't know what these look like, just rattle off a bunch of ordered pairs. Make yourself a little chart, x and y, and put in your buddies here, -1, 0, 1, maybe 2, -2 in there, and find those y values. This is what we did in the previous section. So we know what this one looks like. Goes through 0, 0. Put a 2 in there, we'd get 8, so it'd go way up. And put a -2, we'd get -8 and go way down, right? So we should at least know what these look like. And I guess maybe this one too, right? So point is, we can just plot a bunch of points. We're going to talk about functions of this specific form later. We're going to talk about functions of this specific form later. So be aware that these are things that we're going to talk about in more detail later. But for now, we're just kind of glancing over specifics and just saying, hey, I know what this graph looks like, and we're going to do some transformations. All right, so we're starting out with vertical shifts. Vertical shifts are going to be the easiest things that we do. When we write something, okay, so let's just draw a general function here. So if I draw a function, it looks like this. How wonderful. This is y equal f of x. So this is the graph of our function where y is equal to f of x. So every single point on this graph here has the form points. Come on, get out of here. Points. That's not working for me. Points have the form x comma f of x, right? So when we take and we add something to just f of x, we're adding to the y coordinate, right? Adding to f of x is adding to the y coordinate of ordered pairs. So if we have a positive number, right, if we have some positive number k, and I add that to this, I want to add it to the function value, well, we're adding that to all of the y coordinates, right? So if we would draw a picture of that, and I wanted to draw y equal f of x plus k, well, we're shifting it up. We don't really know what k is, but the point is that we're shifting it up, right? Because all of these y coordinates are getting, some number added to it, right? And similarly here, when we subtract, we could draw that. Maybe we'll put that in blue. We can subtract, right? And we would go y equal f of x minus k would be here, right? So let me get rid of this. And we're moving up and down, well, because we're adding and subtracting from the function value, right? The function value is the y-coordinate. So let's look at an example here. And we want to choose one of our buddies here. So usually we want to take this one and think about this one because we can just immediately draw that parabola. We know what it looks like. We're familiar with parabolas a little bit, at least from previous coursework. So let's take a look at this. Y equal, well, let's use function notation. So f of x equal, well, x squared minus 3. Okay, so if we look at this guy, what we're going to end up doing for pretty much all of these, we want to sort of get into the habit of deciding for ourselves what it looks like first. So we want to think about the general functions that we know, all right, and those would be these guys. And we want to say, well, which one of that does it look the most like? And that's going to be our general strategy, is that this guy, well, I got a square on my x, so that's going to look like y equal x squared, right? And we know what that looks like, and we could just immediately draw it, right? We know that 0, 0 is on there, 1, 1, negative 1, 1 is on there. Okay, so that's our graph of y equal x squared. Now, that's not what we want. We want the graph of this one. Well, we're just going to take all of the y coordinates and we're going to shift down 3 units. So we're going to take all these y coordinates here and we're just going to go down 3, and that's it. So 1, 2, 3, and we would take, and we can absolutely just count. So we start up here at y equal 1, go 1, 2, 3 down, we're here. We count 1, 2, 3 down, and we're here. Count from 0, negative 1, negative 2, negative 3, so we're here. And we can draw the beautiful shift here. So we can observe that the parabola has moved down 3 units. So something that we ought to absolutely keep in our pocket is that we can check ourselves by plotting points. And we did this all last section, right? We plotted a bunch of points. We said, hey, that's on the graph, and we drew pictures by noticing a pattern of the points. We always want to be able to fall back on that, right? So if everything else fails, we can always plot a whole bunch of points. And that's going to be really inconvenient for us, but we can still do it. It might take us 10 minutes instead of 2 minutes, but hey, the task is going to get complete. So that's our goal. So, kind of whatever we can do to make it happen, we got to make it happen, right? All right, so anyway, we can verify that we did the right thing by plotting points, right? So if we put in x equal 1 into our function, we need that to be, what do we need that to be? Well, this ordered pair here is 1 comma negative 2, so we need that to be negative 2, right? So, well, check, right? F of 1, we would plug that into our original function. So we got 1 square minus 3, and lo and behold, that is negative 2. So hey, it worked. Something else we might want to check is the other point, right? Negative 1. We need negative 1 to also be negative 2. Well, turns out that's true as well. How about 0? If I put in f of 0, if I put 0 in there, I ought to get negative 3. And, if I put a 0 in there, well, we do get negative 3, right? So anyway, we know this, right? We can plot points and we can verify that these points are on the graph. But we really don't want to do that to draw the picture, right? Because it's so much easier to just say, hey, I know what x squared looks like. I'm going to move it down 3 units. And then lickety split, it's over, right? We're done. So we can absolutely draw these things by doing what we just did here, right? So draw what it looks like first, and then we do the transformation. Here it was easy, right? We're just subtracting a 3. Eventually it's going to get a little more difficult. We're going to have to do like 2, 3, 4 steps in sequence. But for now, we're just doing one transformation. So what we're about to do here is going to look a little goofy and maybe unnecessary. But in the future, this method is probably going to be more efficient for us because, drawing graph after graph after graph, that gets a little tedious, a little repetitive. And if we don't need to do it, we don't want to, right? So what I would do if I were you is I would grab on to my points that I start with. So I know that I'm going to start with, let me get rid of this. So I'm going to start with our graph of the original, what it looks like, right? So I start with these 3 points. I know that those are there. So I know that negative 1, 1 is there. I know that 0, 0 is there. I know that 1, 1 is there. Now our first step and our only step would be corresponding to that -3. So first step would be down 3 units. So we go down 3 units. And to do this, we're just going to subtract 3 from our y coordinate. So to get to these points here after this transformation, we're just going to go down 3 units. So we're subtracting 3 from y. So we go -1, -2. We go 0, negative, we're going down 3, right? -3. And then 1 goes down 3 units, would be at -2. And that's where we end, right? Because that's the only transformation that we did. Well, now I've got these 3 points, and we can put them on a graph without even drawing the first one, right? We know that the points are there. Well, we know that these original points are there, and we don't necessarily need to draw it if we don't want to. I mean, we certainly can. I don't want to tell you that you can't, but it's unnecessary, right? So 1 goes with -2, -1 goes with -2, 0 goes with -3. And then, the pattern emerges, right? So super. So this method here, it's going to make a lot more sense for you to do this when we have more than one transformation going on. It's going to really streamline your work. But I mean, if there's just one transformation going on, this is, seems cumbersome, and maybe we don't need to do that because we can just kind of spit out those points. All right, great. So we got vertical transformations. We go up and down if we add something just to the function value. Okay, so now we're going to shift left and right. So something kind of funny happens here. If we've got a function and we got some positive number, we're going to add just to the x. Only to the x we're going to add. So something weird happens here. Let's observe something in one dimension, and then maybe we can carry that on to kind of make sense of what we're doing here. So we know how to draw a picture of a point on a number line, right? Let's go up here for just a second. So if I want to draw x equal 2, I can draw it on a number line, right? Hey, there's 2. Yay, right? We can draw 2 on a number line. So what if I want to draw x plus 2 equal 2, right? I want to add something to x. And I want to see what happens. Well, if I want to draw this, I would have to solve for x to find out what x would have to be, right? So if I added 2 on this side, I want to move it to the other side. So I would have to subtract that 2. So I would have x equals 0. So it turns out that if I added a number to x, it ended up shifting the actual point left 2 units. And that's kind of counterintuitive, right? We would think that if I'm adding a number to x, I would move right. But that's not the case here. So we're just shifting over what needs to be in this position to make that a true statement, right? So that'd be a 0. So we can take this sort of idea and we can, well, kind of hand-wavingly move it into 2 dimensions. If we have a graph of some function, let me draw this with green maybe. We've got a graph of some function. Maybe it looks like this. Here's our graph, y equal f of x. And if I want to add a number, we're going to move left. So this hopefully won't get too terribly cluttered. We can move left. If we add something, and similarly, we're going to move to the right if we subtract something positive, right? So we go like this. So if we subtract from x, we're going to move to the right. If we add to x, we're going to move to the left. So let's take a look at one of these. We can do something that looks maybe really, really similar to the one we just did. So let's have maybe our function be x minus 3 square. So this looks really, really similar to what we just did, but it's not the same, right? The grouping symbols in particular, these are what's changing, right? So we're adding or subtracting only from that x value. So that's going to indicate that we're going to move to the right with this one. So we go right 3 units. So we can do the same thing if we want to. We can start, we know that it looks like that square function, right? And we know that we have points on there that we can start with. So we're going to start with -1, 1, 0, 0, and 1, 1, right? Because we know, in our hearts, we know that this is that parabola, right? And we know that these 3 points are on there. Okay, so we only got one step here. Let me call that 1. So our first step here, we're going to go right 3 units. And to accomplish that, we're going to move the x coordinates. So we're going to add 3 to the x coordinate. Okay, so then we just add 3 there. So adding 3, we would get a 2. Adding 3, we get 3. Adding 3, we get 4. And that's where we end. So we can take those ordered pairs and we can plot them. So 1, 2 goes with 1. 3 goes with 0. 4 goes with, I screwed that up. Oops. We didn't move the y coordinate, did we? So that's got to stay at 1, right? We're only adding 3 to the x coordinate, not moving the y coordinate. So, oops. So 4, 1. One of the kind of convenient things about doing transformations is that we know the general shape of what it should look like. So even if I would have drawn that point in there, that doesn't fit, right? That doesn't fit the pattern that I know has to be there. So I mean, right away we recognize that mistake, and that's a good thing, right? So our familiarity with the easier graphs is going to really help us a lot here. Okay, great. So now we, connect dots. So this is y equal f of x. Okay, super. So we added 3 to all of our x coordinates. So we're not going to get too terribly crazy right away. We're just going to kind of take these one at a time, each transformation one at a time. At the end, we're going to put them all together. But for now, we're just going to take the easy ones and we're just going to go one at a time. Something to remember again that I forgot to mention here. So we can always check by plotting points. So if in particular I need f of 3 to be 0, right? If I go to my original function and I put 3 in for x, I have to get 0, and that's going to give you that point right there, right? So if we do that, put a 3 here, we do get 0, and it works. And it's going to work. So just make sure you're verifying that you're doing the right thing, right? On the computer, it's going to give you options. It's going to say, here are 4 options. Choose the right one. It's going to be real easy for you to just kind of guess at those. I would very much encourage you not to, because you're not going to have multiple choice on if we're doing these things by hand. We'll actually have to draw these things. So make sure you're actually drawing these. Okay. So let's do, oh, good. We get to do 2 at once here. So with these easy ones, the up and down, left and right, these guys, we can do these in any order we want. So if I take, let's look at an example. If I have a point right here and I moved it down and then right, wouldn't that be the same? I would get to the same point if I did the right movement first and then the down. So we would get to the same point regardless of the order that we do this. So these are quite easy to do together. But we ought to start thinking about order of operations sort of things. For example, if I took the point 1, 2, and if I wanted to move this up and reflect it about the x-axis, does that matter what order I do this in? So if I want to move up, reflect about the x-axis. So if we wanted to do both of these things, does it matter which order we do it? So if I take and I do this first and this second, well, I would go up here and I would reflect about the x-axis, so I would be down at -3, right? Now compare that to what would happen if I did this second and this first. So if I did this first, I'd be down here for my reflection, and then I want to move up, I would be here, right? That's two different points. So be careful about this. Order is absolutely going to matter, but for now, these two operations, right, left and right, and up and down, it doesn't really matter what order we do these in. Word to the wise, or pro tip here, do the stuff closest to the X first. So we want to do this first and this second. And that's just going to get us in the habit of doing the right thing in general. We're going to want to start close to the X and move away in the future. So let's just kind of get into the habit of doing that. Okay, so let's do it. So this one looks like y equals square root of x, and we know what this one looks like, right? If we need to remind ourselves, plot some ordered pairs, and we can do that, right? So it looks like this one. So what we're going to do is we're going to start at these points. So I got 0, 0, and we've got 1, 1, and we've got 4, 2. All right, and then we perform these operations. So our first thing we're going to do is we're going to go, what does that adding do? So we're adding to x. This means we're going to go left 3 units. So we're going to subtract 3 from x. Okay, so all these x values, we're going to subtract 3. So I've got, get out of here. We got -3, right? 0 minus 3 is -3, and the y coordinate doesn't go anywhere. We got 1 minus 3 would be -2, and the y coordinate does not go anywhere, still 1. And then our other guy, we're going to move that one left 3 units, so we go to 1, right? 4 minus 3 is 1, and then that y coordinate doesn't go anywhere. All right, and now we want to do that second operation. So we're going to go down 2 units, right? Because this 2 is only affecting the whole function, right? It's not just the x, it's affecting the whole function. So go down 2 units. So we're going to subtract 2 from y. And we can do that, right? -3 goes with -2. -2 goes with -1. If we subtract 1, subtract 2 from 1, we get -1. And then subtract 2 here, we're going to get 1, 0. Okay, and then that was it, right? That's the end. So let's go to the picture. We've got -3, -2, boop, -2, -1, boop, 1, 0, 1, 0. And then, we know that it looks like this, so we can kind of draw the pattern. Okay, super. If we want to do the series of graphs, we can totally do that too, right? Because we're going to have these points. We would have 1, 2, 3 goes with 0, -2 goes with 1, 1 goes with 2. So this would be our first transformation, right? Those are these points. And then we would go down 2 units from there. So we're taking all these and go to, down 2 units, and we would get that one. Okay, so we sure can do the series of graphs method, but I sure do think that just writing out what the ordered pairs are is probably a bit easier, because we know what the pattern is, right? We know kind of just basically what it looks like. Okay, so we need to also keep in our back pocket how we check ourselves, right? Check by plotting points. So in this case, we need f of -3 to be -2. So we would go back to here, plug that -3 in there, see what you get, and we do get -2, right? We also need f of -2 to be -1, and we can plug that in, and we can show that that's true, verify that we got it right. We can verify these things in a couple of different ways, but plotting points is usually the best way to verify these things. Okay, so those are the easy ones. Let's do the hard ones. If we take these one at a time, though, they're not so crazy. So we talked about reflections back when we talked about symmetry, right? So we're reflecting a graph. So if we're going to graph this one, well, aren't we just taking, if I have a function and it looks like this, here's y equal f of x. If I make all of those y values negative, Like if I made this y value here negative, it would correspond to a point down here, right? And if I made this y value negative, it'd be a point down here. This y value negative would be like right there. And you know, all of these, if we made them all negative, we would just have a reflection. Boy, how beautiful is that? So right, we're just reflecting about the x-axis here. So if I make f of x, if I make that value negative, we're going to flip it about the x-axis. So if I make the y values all negative, it just puts them all below the x-axis. Similarly, if we take our x coordinates and make those all negative, we're going to be reflecting about the y-axis, right? So any point here would be reflected, point here would be reflected, point here would be reflected, right? And we would have a beautiful reflection of this. Whoa, it went away. And this is our y equal f of negative x. So if we make the x negative, we're going to be flipping it about the y-axis. Okay, so let's take a look at an example here. So let's do y equal let's do negative square root x, and let's do this one, right? Because these are really similar. And let me maybe call these by function names. Let's call that f and let's call that g. So these both look like y equal square root x, right? And we've got this picture in the back of our minds. We got 0, 0, we got 1, 1, we got 4, 2. Let's pretend that goes through that point. So we know that what it looks like, right? Here's y equals square root of x. Well, this guy here on the left, we are multiplying the whole function by a negative number. So this transformation here will be, if I make all of the function values negative, we're going to flip about the x-axis, right? If I make all of the y values of a function negative, it just flips it about the x-axis. This one, our transformation here, is making all the x values negative. So this is going to flip us about the y-axis. Okay, so both of these at the same time, we can do these both at the same time, right? So we would start at the same points, 0, 0, 1, 1, 4, 2. So we're starting here, and then we do the flip, right? So I'm not going to write that again. We're just going to flip it about the x-axis. So we're just going to make all these y values negative. We got 0, 0, we got 1, negative 1, we got 4, negative 2. And that's it, right? That's the only transformation. We can do the other one at the same time, right? We're going to start at the same points. So we got 0, 0, 1, 1, 4, 2. And we're going to do our transformation here. I won't write that again. So we're flipping this one about the y-axis. So all the x coordinates are becoming negative. And then we can end there, right? Okay, so if we drew these graphs, I think I need a little more room. All right, so if we draw these graphs, and again, we recall that we're starting here, our graph over here, well, it's going to end at 0, 0, 1, negative 1, 4, negative 2. So there, how beautiful. And if we look at this guy, this is y equal f of x with our notation. And then if I draw this one, we got 0, 0, negative 1, 1, and then negative 4, 1, 2, 3, 4 goes with 2. All right, there's y equal g of x. Okay, so we've got reflections. So yeah, for now, let's just deal with only one at a time here, and we'll put it all together at the end. So we've got yeah, reflections. Okay, vertical scalings. This is again something that's happening when we multiply by a, or whatever this a value is. So if our a is positive, and we multiply the whole function by it, So we're multiplying our function values by a. Well, we're multiplying all the y coordinates by that number. So we would call that a vertical scaling by a factor of a. So let's look at this one here. Well, I guess we've been drawing the general picture. Let me draw that general picture. So if I've got a function that looks like this, I can draw a picture of a vertical stretch. Pretend that's on the x-axis. So this would be y equal a times f of x. And if my a value is bigger than 0 and less than 1, then it's going to be down here. Right, so that's y equal 1 over a times f of x. And let's say a bigger than 0, right? Let's maybe have it be bigger than 1. Okay. All right, so more or less, if we're multiplying by a fraction, we're going to shrink it. If we multiply by a whole number, we're going to make it bigger, right? Or I guess specifically a fraction between 0 and 1, right? If we multiply by something bigger than 1, then we're going to stretch it. All right, let's take a look. Y equal maybe, get that little mark out of there. So let's have another familiar one. So let's do 2x squared. All right, and maybe we can do another one at the same time versus f of x equal, or g, let's call this g. Maybe 1/2 x squared. Okay, so we're going to take all of our y values, so that transformation here, we're going to multiply y values, all of them by 2. And on this one, we're going to do the same thing, multiply y values by 2. So we can do that. We already know what the standard one looks like, right? So both of these are going to look like that parabola, right? And we already know where we're going to start. We've got -1 goes with 1 on the regular old parabola, right? 0, 0 is on there, and 1, 1 is on there. And if I do my transformation, I'm going to multiply all these y values by 2. So we got -1 goes with 2, 0 goes with 0, 1 goes with 1. Excuse me, we're multiplying the y values by 2, so that would be a 2. And then that would be it. And we can draw our beautiful picture, right? -1 goes with 2, 0 goes with 0, 1 goes with 2. Something to notice here is that vertical scaling did not affect that x-intercept, right? Because the y coordinate was 0. If I multiply anything by 0, it's always, always, always 0. So that vertical scaling did not affect x-intercepts. That's going to come up later when we're talking about polynomials in general. So take that to heart, I suppose. Okay, so let's do this other one. So we're going to start at the same points. And we're going to just apply the transformation. So we're going to multiply all these y values by, I've written 2, but I meant to write 1/2, right? Because that's what we're going to multiply by. All right, so we multiply everything by 1/2, the y values. So I got -1, 1/2, 0, 0, right? 0 times anything is 0. And then we've got 1, 1/2. All right, and we can draw this picture. So 0, 0 is there, 1 goes with 1/2, -1 goes with 1/2. So it's kind of shorter and wider, right? And this other one is taller and skinnier, right? So yeah, multiplying by a number that is larger than 1 by the whole function, it's going to stretch us vertically, right? And this one here shrunk us vertically, right? All right, super. So yeah, vertical scalings, we're going to multiply the whole function by some number. Horizontal scalings are going to be when we we're going to mess with x, right? So horizontal scalings. When we did the vertical up and down, and we did the left and right, we're going to mess with y when we're moving up and down, and we're going to mess with x when we're going left and right. Something that we recall when we had the x coordinates changing was that the opposite of what we thought was going to happen, that's what actually happened. So just real quick before we draw that general picture where we have, the function y equal f of x. Before we do this, let's do something similar to what we did above when we talked about horizontal shifts, left and right. So if I think about a number line, So if I want to draw a picture of x equal 4, right? I can draw x equal 4, right? Here's 4. Great, there's 4. How wonderful. Now consider if I want to draw 2x equal 4. Well, I want to draw the same thing, right? I want to draw a picture of what x has to be, but we got to do the same thing, right? I need x alone. So here we would have 4 over 2, so that's 2. So I'm going to take whatever I started with and divide it by 2 if I want to get x alone, right? So then we draw a picture on the same scale here, and we're shrinking it, right? We're getting closer to 0. So moral of the story here is the opposite of what we think is going to happen with x, that's what's going to happen with x. Usually when we see something like this, we're going to say, oh, I'm going to double what x has to be, right? Because it's 2x, I got to double it. Well, the opposite is true, right? If I want to know what x is, if I multiplied a number by x, well, to get x alone, we're going to have to divide, right? So we would have to divide this on both sides. So we're going to have a horizontal compression here. Okay, so great. That's enough hand wavy stuff. So we can draw the general picture. So suppose we got a function and we got some number that's larger than 0. So to graph y equal f of b times x, we're going to divide all the x coordinates of the points by b. So we're going to say we're horizontally scaling by a factor of 1 over b. So if we draw a picture of this, I would, compress it by a factor of b. So y equal f of b times x. And if we have, let's here say b bigger than 1. If we have b bigger than 1, then I would draw the horizontal scaling. I wanted that to be blue. So you got to push the blue button. So a horizontal scaling of 1 over b would stretch it, right? So if we got a fraction or a number that's between 0 and 1 rather, we're going to do the opposite of what we think is going to happen. So let's take a look real quick. So we're about to do everything at once. So hold on to your seats. So let's take a look at y equal, let's use that square root one again. So if I have 2x, and then if I want to do, I can do this one at the same time, right? 1/2 x. Okay, so let's okay, so the same thing is going to happen, right? We have in the back of our minds that we have this picture of what it looks like, right? And here I forgot to call this F, and I forgot to call this G. It doesn't really matter what we call them. It will when we label them, but okay. So y equal square root of x. We know that this looks like this guy, right? And we got 0, 0, we got 1, 1, we got 4, 2. We got those points. So we just follow what we're doing up here, right? We're going to take this guy, and that's going to be our first transformation. We're going to multiply, or maybe I can write this in a different way. So let's divide all x coordinates by the number that we're multiplying by the x. So here it's 2. And on this one, we're going to do the same thing. Divide all x by 1/2. which is going to end up being a multiplication by 2, but that's just the way fractions work, right? If I if I divide by a fraction, that means I'm multiplying by its reciprocal. That's pretty ugly, multiply. I don't know, we could probably argue that that's just as ugly as what was already there. So that's multiply, right? Multiply by 2. Okay, so we can start at the points that we know have to be there. So we got to have 0, 0. We got to have 1, 1. We got to have 4, 2. So then we do our transformation. We're going to divide all x coordinates by 2. So 0 divided by 2, that gives you 0. 1 divided by 2, that gives you 1/2. 4 divided by 2, that gives you 2. And there we go, that's it. And okay, and we can do the other one, right? So we can start at the points that we know are there, right? 0, 0, 1, 1, and then 4, 2, right? We know that those are there because we know what that general picture looks like. And now we're going to do our transformation. So we're going to divide all of our x values by 1/2, which means we're multiplying them by 2, right? So 0 times 2, that'd be 0. 1 times 2, that's 2. 4 times 2, that's 8. All right, so if we're going to go and draw, I need a little more room again. All right, so if we're going to go draw these, this one here, we would have 0, 0, 1/2, 1, and then 2, 2. So it'd be, like that. And then we can draw this one. We got 0, 0. We got 2, 1. And we got 8, 3, 4, 5, 6, 7, 8, 2. So stretched out. So something, kind of counterintuitive happens, right? When we multiply the x value by some number, we're going to divide all the x coordinates by that. And maybe this is y equal f of x. This is y equal g of x. If we would draw the original function on the same coordinate plane, let's do that real quick. Right, and this we can think about that as sort of squishing it toward the toward the y-axis. And this one, we got that one, 4, 2. And this one we can kind of think about stretching it out further than, the y-axis. Okay, super. Now we're going to do everything all at once. And the key here is not to panic, right? We're going to have a whole bunch of letters and numbers flying around here, and we just got to not panic. The order in which we do these operations is right here. Think about that PEMDAS thing, right? We have an order of operations this is the order that we do operations in. Well, this is an extension of order of operations. We probably won't get into it too terribly much, but here is the order in which we perform these operations. So we're going to start with the first thing. So if we have a function that looks like this, let's take a look at something specific. Let's look at something specific. So here's a function, f of x equal, we'll just make one up, -3, 2x plus 1. We deal with the square one because we like that one, right? So here is something that looks like this, right? So I know that my original function would look like this, and now I'm messing with it, right? So we're multiplying the whole function by -3. So in this case, that's going to be our a. I see now that there's a typo here. There should be a k right there, right? Because if we're going to refer to a k, there ought to be a k there. So when we're looking at what this function looks like and trying to compare it to what we've got up above, that -3, that's going to be that a. This 2 here, that corresponds to b. 1, that corresponds to h, and this one corresponds to that k. Okay, so we can line this up and say, oh yeah, we got the picture. Okay, so let's do this. We want to do these things in order. So the first thing we're going to do is subtract h from each of the x coordinates. So let's label these. This thing is going to be our first step. and we're going to, let's write what we're going to do. Subtract 1 from the x coordinates. Okay, got it. And then we're going to do this thing next. Right, divide all the x coordinates of the points in the graph obtained in step 1 by b. So we're going to divide everything by 2. So we're doing all the x stuff first. X stuff first. Let's look at one of these where it's negative next time, because we can combine those steps, right? If we're multiplying something by x, we can just roll that negativeness in there as well. So 2, we got it, done. So that was our second step. Third step, multiply the y coordinates of the points in step 2 by a. So that's going to be this number right here. So that's our third step. Third. Divide. Nope. Multiply the y coordinates by a. Multiply y by -3. And then our fourth step, we're going to add k. So fourth step is right there. So we're going to add 1 to all the y values. Right? And that's going to correspond to our to our up and down, right? Up and down movement. So great. I would very much encourage you to list this out in steps, right? 1, 2, 3, 4. We do the stuff with the x first, then we move out from the x and we go for it. So let's do it. So we know that we start with the same points every time. We got 0, 0, we got 1, 1, we got -1, 1, right? So we're going to start at -1, 1, 0, 0, and 1, 1. All right, and then we do our first step. So our first step here, we're going to subtract 1 from x. So all these x values, we're going to subtract 1. So we got -2, 1. I got -1, 0. I got 0, 1. Super. Done. Boop. We want to do the step 2 next. So here's step 2. We're going to divide all the x values by 2. So dividing all these by 2, we're going to have -1. We got -1/2. We got 0 divided by 2, that's still 0. Great. All right, so now our third step, we're going to multiply all these y coordinates by -3. So check it out. It's negative in front of there. So this is going to have a reflection rolled up into it. And we don't even have to do any extra work, right? So 3, we're going to multiply all the y coordinates by -3. So we got -1, -3. We've got -1/2. 3 times 0, or -3 times 0 is still 0, right? And we got 0, 1 times -3 is -3. That is wonderful. And now we have one more step to do. We're going to add, subtract, subtract 1 from all of these x values. So we can do it, right? We got -1 goes with -4. Hold on. Subtract from the x. Subtract from the x value. So -1. What am I even looking at? I want to look at 4. I'm looking at this one. I shouldn't be looking at that one. I need to be looking at the fourth step, right? Fourth step. We write all these things to stay organized. So we got to stay organized, right? So add 1 to the y values. We're adding 1 to the y values. Sorry about that. So -1 here, add 1 to the y value, we get -2. -1/2, add 1 to the y value, we get 1. It's kind of screwy looking. So we got -1/2, comma 1, right? We moved it up 1 unit, and then we got 0 goes with -2, so up 1 unit. So we've ended here. So we've got 4 steps, and we've got a clear roadmap of how we do these, right? We've got an order right there. How beautiful. And now we can draw our picture. So we draw our picture. So -1 goes with -2. Boop. -1/2 goes with 1. All right. And then what? 0 goes with -2. And then we see the pattern. we know that in the back of our minds, we know that we're transforming something that looks like this, right? And thinking about these transformations, what did we do? We moved it left. So we're going to take this thing and move it left. We're going to switch it down horizontally, right? So it's going to get, moved horizontally, squished. We're going to multiply by -3. So that's our reflection. So we're going to end up reflecting it too. So this is, that's a reasonable pattern, right? So here's our picture. And further, check it out. We can check ourselves, right? Check by plotting points. So if we put in, if I put in -1/2, I need this to be 1, right? And plug it into the original function, right? F of -1/2. This is -3 times, what was it? 2x plus 1. So we got 2 times -1/2 plus 1 square plus 1. So look what happens. So we've got here, that's 2 times -1/2, that's -1. Plus 1 would be 0. Well, that's 1. So that worked. That's awesome. We can do the same thing with f of 0, right? If I do f of 0, I need that to be 2. Well, is it 2? Well, 2 times 0, that's 0. 1, so we got -3 plus 1, so -2. And yeah, hey, it worked, right? That gave us that point right there. So, check yourself by plotting points, and we can verify that we did it right. And we drew the beautiful picture. Okay, so what usually happens is we get questions about the ones that we don't know what they look like. Maybe we're given a graph. Let's do one like this. Let's say 3, 1, 2, 3, 4. Let's just put some just random points out there. So let's have -2, 0. Let's have 1, 3. Let's have it connect. And let's then go to maybe 2, 1. And then let's go to 4, 3. So here's our graph, y equal f of x. Well, I don't know. There's no general form of this, right? And I'm not even given an explicit formula for it. But that doesn't matter. Here's the function, right? It contains these 4 points, and all of these points are connected. I forgot to put a -1 in there. Sorry about that. Okay, so we have all of these points, and we have that they're connected, right? So I want to draw y equal g of x equal, let's have 2 f of 1/2 x minus 1 minus 2. Okay, so we can do this in exactly the same way. We're going to just take these points that I know are there, and that's where we're going to start, and we're just going to do all of our transformations. So we can list them all in the same order again. So this thing is what we're going to be doing first. So when we subtract from x, we're going to be adding, right? So we add 1 to the x values. Second thing is we're going to divide x values by 1/2, or we could say multiply by 2, right? Then we move outside, so this 2, so our third step, we're going to multiply y values by 2, and then our fourth step, we're going to subtract 2 from y. Let me change this just a little bit, and we'll have a reflection as well. So let's do this. Let's have that be negative, and that's a negative. So we've got a reflection in there as well. How wonderful. Okay, so we're gonna do this just the same way as we did that other one, right? We're gonna start at the points that we know have to be there. So -2, 0 has to be there. -1, 3 has to be there, 2, 1 has to be there, 4, 3 has to be there. All these are connected. We're going to keep that in the back of our head that we're just going to connect the dots once we get there. Just, put the lines there. All right. So what are we going to do? So our first thing, we're going to add 1 to all these x values. So all these x values, we're just moving them up 1 unit. So -1, 0. Adding 1 to this one, we get 0. Adding 1, we get 3. Adding 1, we get 5. Great, we did it. Step 1, done. Step 2, we're going to divide all of the x values by -1/2. So dividing by 1/2, we can also say that multiply by -2, right? It's the same thing. Divide by -1/2, multiply by -2, it's the same thing. So we're going to multiply the x values by -2. So -1 times -2 is +2. 0 times anything is always 0. 3 times -2, that's -6. And then 5 times -2 is -10. Okay. Great. So we got that finished. We're moving to the third step. So we're going to multiply all the y values by 2. So all of these y values are just going to get multiplied by 2. Everything stays fixed other than that. Just multiplying everything by 2 there. Great. And now we got our fourth step there. So our fourth step here, we just did the third step. Fourth step, we're going to subtract 2 from our y values. So all these y values are going to just move down 2 units. Right, just subtract 2 from all these things. And that's where we end. Right, that's with our ending step. And we can draw the beautiful picture. So we've got 2 goes with -2. Boop. 0 goes with 1, 2, 3, 4. -6 goes with 0. 1, 2, 3, 4, 5, 6 goes with 0. And then -10 goes with 4. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 goes with 4. So up here. And then we would connect the dots. How beautiful. So what we ought to do is maybe compare it to what we started with. We knew that we were going to do a vertical stretch, horizontal stretch, and we're going to move it left and right. And we knew that it was going to reflect because we had a negative on the x. We knew it was going to reflect about that x-axis. So picture in your mind doing these transformations on these points, and we're going to end up here, right? So we flip this about the y-axis, stretch it, move it down, move it right. And then, yeah, that's it. The questions for these, they might ask you questions like, what is f of 2? And in this case, we would say f of 2 is, -2, because we can take our points that we found and just refer to them as the function notation, right? This is, if I have the point 2, -2, this is the x value, and this is the f of x value, right? Okay, but we knew that because that was from the last section. Okay, so it kind of seemed like we just kind of jammed our foot on the gas pedal for those last 2 examples. But try some simpler ones, like maybe just do two transformations at once, and that'll kind of get you to get the hang of it. All right, well, yeah, that's it for section 1.7. Really want to stress very much that we can plot points to draw graphs, and we can always fall back on plotting points, but it's a terrible primary strategy because just plotting points, we're going to have to draw a whole bunch of them if we want to see the pattern or know exactly what the pattern is, because maybe it could be that I take my parabola here and maybe my stretches and compressions and shifts move it down here. I keep hitting that scroll bar. So maybe the stretches and compressions take you down here, and you'd have to be choosing x values in here to find the pattern, right? If you choose your buddies, -1, 0, and 1, in this case, then you're going to get values way down there, and it's going to be really hard to see a pattern. So, yeah, plotting points is great for checking yourself. But as far as actually doing these problems, you don't want to plot points. Okay, great. So yeah, thanks for watching the video. Have a great rest of your day.